Bienvenidos, Ushamadid, and welcome UMGC learners from the CMIT-455 Section 6380 course. This is the CCNP ENCOR version 8 course from the Cisco Networking Academy for the spring 2021 semester. In this tutorial video, we're going to be taking a close look at Packet Tracer Activity 6.2.1, where we're going to learn how to configure IPv4 and IPv6 static and default routes. We're going to learn in this video about next hop static routes, which are also referred to as recursive static routes. And then we're going to discuss whether or not recursive lookups are actually taking place. We're going to look at the forwarding information base, or the FIB, as well as the adjacency table on two real physical Cisco routers. We're also going to look at directly connected static routes and fully specified static routes. And we're going to address the message you see when you're using directly connected static routes that tells you that if it's not a point-to-point interface, you might want to consider using a fully specified static route. And we'll talk about the reasons as to why that is, why you see that message. So let's take a look at the topology we're going to be working with here. In Activity 6.2.1, you can see we've got our addressing table, which has been provided to us. I like the topology we're working with here. We've got an edge router connected out to two internet service providers. We've got the ISP LAN. You can see the L is cut off there a little bit, but we have the ISP LAN out to a customer server out here somewhere on the internet. So let's go ahead and dive in. We're going to be configuring IPv4 static and floating static routes. Again, floating static routes, another kind of route that we're going to be working with. So configure an IPv4 static default route. So on the edge router, we're going to configure a directly connected IPv4 static route. Well, what does that mean? Well, if it's directly connected, we're saying that we're only going to be referring to the router interface, the outgoing or outbound router interface. Now, the primary static route should point to ISP1. Now, here's the beauty of the directly connected route. I don't need to know the next hop IP address of the ISP router. I only need to tell the edge router that for all default traffic, in other words, for all traffic for which I do not have a longer, more specific match in my routing table, I'm going to send that traffic out this interface right here. And so if I click into this activity and hover over, we're looking at serial 000. Now, remember, this is a point-to-point interface. And so using a directly connected static route is 100% legitimate, right? This is an absolutely correct way to go ahead and perform default routing when we have a point-to-point serial interface, because there are only, by virtue of the fact that this is a point-to-point interface, it's important to point out that there are only two things that can be involved here. There are only two devices on each end, or I should say one device on this end, one device on that end, because it's point-to-point by definition. You're only going to have two devices on that are involved in the communication here. So all I need to do is tell the edge router, throw that traffic out serial 000. So let's get onto the edge router. Let's go from user exec to privilege exec, and let's first take a look at the routing table. As you can see, the gateway of last resort is not set. And so that's what we're going to be doing here. So we'll go from privilege exec into global config. We're going to say, we're going to say IP route quad zeros, meaning all routes. Basically, the quad zeros back to back right there mean all routes. Remembering that if I have a longer, more specific match, that is the route that would be matched. However, here I'm just saying this is my default static route, and if I do a question mark, you can see that I could put the forwarding router's address, or I could use an interface. And so I'm basically going to say serial 000, and we should receive a few points for that, and we do. Now, here is the message that you will receive from time to time when using or configuring a directly connected static route. It says the default route without the gateway, if not a point-to-point interface, may impact performance. And what that means is there may be an ARP packet or an ARP process that takes place. However, ARP is not used on point-to-point serial interfaces. Let me say that again. ARP, the address resolution protocol, is not used on point-to-point serial interfaces. On a multi-point configuration or an Ethernet configuration, yes, you could end up with ARP being used. So that is why you're seeing this message. But we're on a point-to-point serial interface. The impact or overhead of ARP being performed is a moot point. And let me now, and this is a great place, let me see if it says do show adjacency. So the adjacency table and the CEF table, I'm sorry, the FIB, those are the two tables that are used by CEF in order to perform Cisco Express Forwarding, in order to perform the forwarding of packets by default on Cisco routers. Can you disable CEF? You certainly can, and that would be what I like to refer to as a resume generating event, right? You do not want to disable CEF. CEF is there to expedite the forwarding of packets through Cisco routers as quickly and efficiently as possible. There are really no use cases that I can think of in a regular enterprise network, and I'm sure you could come up with some corner case where you would want to disable CEF. But again, this is not something that you're going to disable. So let's go to some real Cisco routers here, specifically router 8. And I just said that it doesn't use ARP. So if I say show IPsec, here is the forwarding information base, or the FIB. Now, the FIB is really a copy, so to speak, of what you would see in the routing information base, the RIB. And we see the RIB by saying show IP route. And as you can see here, the information is presented in a different format. However, it's the same information that we see when I say show IPsec. And this is showing me the forwarding information base. Again, for all of these prefixes, we're seeing the interfaces that are associated with the forwarding of traffic. Right? And so we've got a lot of information here. So now there's also an adjacency table. So let's go ahead and say show adjacency. Now, this is a consolidated version of the information that's actually being kept here in the adjacency table. You can see that the serial interface is listed as point-to-point, where here an Ethernet interface actually shows the next hop address, which is 10.0.0.9. We're on router 8, which is why I know the .9 means it's router 9 out that interface. And again, I created some static routes that point out these interfaces. But what if I was to say, show adjacency table detail? And let's go down a little bit further, and you can see there's a detail option here. And so this is going to show me some much needed detail to understand the statement I made that ARP is not used on the serial interfaces. Because if you take a look down here at the Ethernet interface, what do we see? ARP. And so if on an Ethernet interface I was to use a directly connected static route, in other words, to configure something like this, IP route, and we'll say to get to the 172.16.10.0, and we'll make it a /24 network, go out the fast Ethernet 00.10 interface. That is a directly connected static route. It goes out an Ethernet interface, meaning there is going to be ARP overhead with this configuration, right? And you can see ARP is running here. However, on the serial interface, you can see it's a point-to-point adjacency. There is no ARP being done here. You'll also notice that there's no MAC address on the serial interface. Because I don't need a MAC address, we don't need ARP, it is a point-to-point interface. And you might be saying, well, wait a second, there's no way that that is the MAC address of this interface. Well, the MAC address is in there, and if I'm not mistaken, it should be, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That should be our MAC address right there. And how can we check that? Do show interface fast Ethernet 00.10. And you will see 0026, right? This is the hardware burned in layer 2 MAC address of this interface, BIA, burned in address. And there it is, 0026, 0 Baker 3 Delta 5298. And so you can see that the MAC and ARP are in play on Ethernet interfaces. On serial interfaces, they are not. And if you're thinking, well, is that the MAC address? No, this is indicating IP, the Internet Protocol, that's 0800, which is what we see right down here. All right, so it's very important to understand the difference and of why you may see that message. And so we took a look at the forwarding information base, which is the FIB. Think of it as a copy of the RIB in different format. And again, there's different information that we can get out of there that we don't see in the RIB. And then we looked at the adjacency table. And remember, those are the two tables that Ceph depends upon, the FIB and the adjacency table. All right, so now let's transition back. We've created our default directly connected static route pointing to ISP1. Now, we're going to configure a floating default static route. Now, this is very important as well, the concept of a floating static route. If I was to say do show IP route, you can see here that we have this static route directly connected to serial 0. Now, it's directly connected to an interface and it's a static route. So when we talk about administrative distance, remember that the RIB may show it as directly connected, right? And you can see that we see that here for this default static route. It says it's directly connected. Now, if it's not directly connected to an interface, the administrative distance may not show what you think it would show. Because again, directly connected is 0, static is 1. What you would typically see is when it's not connected to an interface, it would show 0, 1, right? And that's because only directly connected to an interface is going to give you the administrative distance of 0. So, and again, we'll see that here as we start to work through some more of these static routes. But these are very important little semantics that you'll run into. So on the edge router, we're now going to configure a directly connected IPv4 floating static default route. This default route should be through router ISP2. It should have an administrative distance of 5. And again, directly connected, meaning this point-to-point interface here. And so if I hover over, serial 001. All right. So IP route quad zeros, right? So there is our static route. We're going to go out serial 001 and let's do a question mark here. And here's where we get to the administrative distance conversation. It's a floating static route because it's not going to be installed into the routing table if and until the serial 000 interface, where our first default static route, directly connected default static route, is operating. If this interface goes down, then this static route with a higher administrative distance of 5 would be installed into the routing table. So let's say do show IP route. And you'll notice there's only one static default route in the RIB, the routing information database. And it's the first one because it has a lower administrative distance, directly connected, right? Has a lower administrative distance than the administrative distance of 5 that we just put on that route. So now we're going to configure IPv6 static and floating static default routes. So in this part of the activity, we're going to do the same thing here on the edge router. We're going to configure a next hop static default route. Now, I think that this is interesting because the text on page 136 talks about, or I shouldn't say 136, it's before that, 135, talks about recursive static routes. Now, remember, I pointed out that the next hop static route is also known as a recursive static route. And we're going to talk about why that is here in a second. But when we're talking about next hop static routes, next hop means we provide the next hop IP address, right? The IP address of the hop we want the traffic to go to next. And learners become confused between the difference of directly connected and next hop. Remember, directly connected is from the standpoint of the router on which I'm configuring the static route. And so it would be this directly connected interface because I'm configuring the static route on this router. And so I would put that interface. What learners tend to do when they get confused is they don't see that as the outgoing interface. They put that serial interface for the static route on this router, and that is not correct, right? When you're using the outgoing interface for a directly connected static route, it is the interface on the router on which that static route is being configured. So serial 000 and serial 001. Remember, directly connected. It's going to be the directly connected interface on the router on which you're configuring that static route. Don't put the directly connected serial interface of the next hop router for a directly connected static route. Now, that is different than the next hop static route. When we're talking about a next hop static route, we're talking about the IP address of this interface or the IP address of that interface. Again, assuming that we're doing it here on the edge router because that's the next hop IP. I wouldn't put my IP address down because that's not the next hop. That is on this router. So let's go ahead and do our IPv6 work here. So on the edge router, configure a next hop static default route. The primary default route should go through ISP1, which is right here. So what do I need for a next hop static default route? I need the next hop IP address. And you can see here, ISP1, their serial interface is the 2001 DB8A11:64. So let's go ahead and say IPv6. Now, we may also see something happen here, which would indicate that we haven't configured this router to perform IPv6 forwarding of traffic. In fact, I'm pretty sure we're going to see a message here, but let's play this out. So I would say IPv6, and again, we're using a default route. So instead of the quad zeros, right, because that's an IPv4 convention, let me go ahead and hit the question mark here. You can see we're going to say IPv6 route. And if I do a question mark, it wants the IPv6 prefix. Well, remember, it's a static default. And in IPv6 terminology, that's : /0. And now it wants either the outgoing interface or the next hop that we're going to be using. Now remember, you can see right here, IPv6 address of next hop. Again, on the other router, not on edge router, not on me, I need the next hop. Where am I sending this traffic to? Well, we have that in our addressing table, 2001:DB8:, where are we at here? DB8:A:1::1. Now, you can see here we could put an administrative distance, right? But we don't have to. And notice I'm not putting the prefix length at the end. It's asking not for the prefix length to be added here. And we'll see, watch what happens when I hit enter. There it is. So now, and again, we receive 6 points or 6% for that. So that is your IPv6 next hop static default route. That is how you basically, the equivalent of the back-to-back quad zeros with IPv4 is represented here with : :/0, again, indicating all IPv6 routes. And then here is the next hop IP address. If it was IPv4 that we were doing this with, for the next hop IP, I would have said 10.10.10.1, right? And just like you don't put in the subnet mask, you don't put in the prefix length for the next hop value that we're using. All right, so let's scoot down a little bit here. So that was our next hop static default route to ISP1. Now let's take a look at configuring an IPv6 floating static default route, which is going to look very, very similar. And it's going to be a next hop IPv6 floating static route that should use ISP2 with an administrative distance of 5. And so this is going to be easy. We're going to hit the up arrow, and I'm going to take a look at this IP address very closely here, and I see that the only difference is :A:2. Now, remember here, this is where we would add the administrative distance of 5 in, so that this is not going to get installed into the routing table, the RIB, the routing information database, that we see when I say do show IPv6 route. And you can see here we have a single static route, a single static default route, and it is a next hop default route. And you notice the difference here, how it says via, right? And it shows that next hop IP. But if I say do show IP route, we don't see a via here, right? We see that it's directly connected, right? We see it's directly connected. So let's cruise down. And now let's take a look at the next ask here, part 3. Configure IPv4 static and floating static routes to the internal LANs. So in this part of the lab, we're going to configure static and floating statics from the ISP routers to the internal LANs, which are these LANs over here. And so step 1 of part 3 on ISP1, and let's bring ISP1 up here. What we're going to be doing here is configuring a next hop IPv4 static route to the LAN 1 network through Edge router, right? So there's a lot going on in that statement. So let's go from user exec, as indicated by the > sign with our prompt. We'll enter the enable command, or just en will get it done, to get us into privilege exec and then into global config. And so we're going to be creating a next hop IPv4 static route. So, and I'll give you my English translation to help you try to remember the syntax here. And what this is saying to me is my route to get to the LAN 1 network, which is 192.168.10.16, and of course they give us a /28 here, right? So here, unlike ACLs, we're not using a wildcard mask. Here, if I do a question mark, you can see it wants the subnet mask. So a /28 would be 255, 255, 255, and then remember, the 28 would indicate that we're borrowing 4 of the host bits in the last octet for network bits to perform subnetting. And so if the first 4 bits get borrowed, they have values of 128, 64, 32, and 16, meaning 128 and 64 is 192, plus 32 is 224, plus 16 is 240, or I should say 228, sorry, and plus 16 it was 220, 224 plus 16 is 240. Sorry about that. Losing it on my math right there. All right. And so that would be the subnet mask that we're going to use. So, and it's going to be to LAN 1. And then we say, how do we get there? Well, we're going to provide the next hop, right? Because this is going to be a next hop recursive static route. So let's come up to the ISP router and let's see the edge router, right? That the ISP router is connected to here. That edge router serial 000 interface is 10.10.10.2. And so I'm only going to put in 10.10.10.2. And again, that is a next hop, i.e. recursive or AKA recursive static route. And again, the translation here is my route to get to this network with this subnet mask is going to be to go to this next hop IP address. And that's one way that you can hopefully, it'll help you remember the syntax if you don't have it in front of you. And remember, you've always got that context-sensitive help with a question mark. All right, so on ISP1, we're going to configure a next hop IPv4, again, recursive IPv4 static route to the LAN 2 network through the edge router. And so here's the LAN 2 network, and again, they're going to give us a 27, which is going to be a 224 in the subnet mask for the dotted decimal notation. And let me center that again. And we're on the ISP router, and so let's make that happen. In fact, let's pull back the previous command. So we know a /27 is going to be a 224 because 128 and 32, sorry, is 196. I think that's where I went wrong in my calculation. So 128 and 64 is 192 plus 32 is 224, and that's our 27. So I apologize. I think I might have said 128 and 64 was 224, something like that. I said something wrong maybe. But there we go. That is the dotted decimal notation for a /27. And what is the network ID? The network ID is 192.168.11, and then the network ID is the .32, right? So this is our network ID, 192.168.11.32. There is our subnet mask, and there is our next hop IP for the next hop, aka recursive static route. So let me say do show IP route. And you can see that we have our two statics right here. And what is different between what you see here and what we saw on the edge router for the routes that we had here? You can see the default static that we created. The directly connected default static says directly connected. However, here we're creating next hop, aka recursive static routes, and so it says via. So it gives the router the next hop IP. So here is where the recursion comes into play in theory, because we need to make sure we're clear on this. When I put this next hop recursive static route into the RIB, the router needs to figure out, it knows, okay, well, that's the next hop IP, but what does it need to know? It needs to know out which interface I'm going to go to get to that next hop IP. Now, you'll see here in the routing table where we have this 10, the directly connected 10.10.10.0, and it shows the local entry as well as the directly connected entry. And this next hop recursive static route will initially, when it builds the forwarding information base in the adjacency table, right? And I put this entry in, it knows that this is the interface out which it's going to go, the serial 000 interface. And now what I want to do is I want to share with you something about recursive routes, right? Because there's a misunderstanding that this recursion is a bad thing or that it's actually happening at all. Because remember, we talked about CEF, Cisco Express Forwarding. behind the scenes, this is what we see when we see the routing table, but behind the scenes, for the routing of this information to take place, you are not going to have recursive lookups repeatedly happening. What is actually happening is what is indicated here. And this is a note from the version 6 curriculum of the Routing and Switching Essentials textbook. And this is very interesting, right? They point out they make a reference to iOS 12. We are way beyond iOS 12. And so I want you to look here. Ceph provides optimized lookup for efficient packet forwarding by using two main data structures stored in the data plane: the fib, which is a copy of the routing table, and the adjacency table, which includes the layer 2 addressing information. The information combined in both of these tables works together so that there is no recursive lookup needed for next hop IP address lookups. So for IP address, for next hop static routes, the information is already there. In other words, a static route using a next hop IP requires only a single lookup when Ceph is enabled on the router. Ceph is enabled by default on Cisco routers. And again, there is no use case that I can think of where you would be disabling Ceph in an enterprise environment. And I'm going to caveat that. Again, I'm sure you could think of one, but I'd be hard-pressed in a normal enterprise environment where you would want to turn Ceph off. So all those static routes that use only the exit interface on a point-to-point network are common. That's the directly connected static route that this is referring to right here. The use of the default Ceph forwarding mechanism makes this practice unnecessary. And what they're saying here is, remember, there's all of this importance placed on the harmful impact overhead of recursive lookups. That, in the use case of a next hop recursive static route, be it a static route or a default static route, if I'm using a next hop or recursive format, meaning I provide the next hop IP address, that is bad, and that I should always use on the serial point-to-point interfaces, the directly connected point-to-point networks that we're working with here, that I should always use the directly connected interface, saying the interface, not the next hop IP. And what this is saying is that is not necessarily the case. Again, I typically, when using point-to-point interfaces, will use the directly connected interface, because it's very easy to do, right? You know the directly connected interface out which you want that traffic to go. But at the end of the day, Cisco Express Forwarding, or Ceph, is going to eliminate the concern about these recursive lookups because it's already sorted that out. And so let's come back to the physical routers that we have here. Router 8. And remember, I said show IP Ceph, and here is the fib, the forwarding information base. Well, if I say show IP Ceph, you can see that I could actually put in a next hop route. And in fact, let me quickly say do show run and include, I can't remember what routes I configured here. Oh, sorry. I thought I was in global config there. So show or include route. So I've created some of these bogus routes here, right? And again, these networks that these routes go to, they don't even exist. But here, you can see, here is our next hop, i.e. recursive static route, because it's saying to get to the 192.168.100/24 network, go to that IP address. Now, this next hop IP exists, and I'll prove that by saying ping 10.0.0.9. Again, it's a fast Ethernet interface on router 9, and router 8 and router 9 are both connected into an Ethernet switch, and they've got connectivity to each other. So that interface is up, and this is a next hop, and actually let me get this out of here. That is a next hop, i.e. recursive static route to get to that network. So what happens if I say show IP Ceph, and I want to go to the 192.168.100.0, And I think we do the /24 in there. Take a look. Cisco Express Forwarding, CEF, already knows, right, that you can see that we're attached to the serial interface. It knows the next hop information here. Take a look at that. It knows that the next hop 10009 goes out what interface. And so as Cisco Express Forwarding is building these two tables, the adjacency table and the FIB, the forwarding information base, it already knows the next hop. And so the idea that there's a recursive lookup that is constantly taking place is not the case, as that note that I just showed you explained and pointed out. CEF knows what's going on. CEF has that information, and you can see it right there, okay? And so, again, there's always concern about the recursive static routes, i.e. the next hop static routes, causing some sort of massive performance hit, right? That is not the case when Cisco Express Forwarding is enabled. Again, saying next hop or saying recursive, think of it as nothing more than a way to describe that configuration command that we're putting in, right? And it's the same thing. Directly connected, I use the interface. Next hop /recursive, I use the next hop IP. And then fully qualified, super easy to remember that, I put in both the interface and the next hop IP. But know that CEF, behind the scenes, leveraging the forwarding information database, the FIB, and the adjacency table, already has all that information sorted out. You don't see it reflected here in the routing information database, the RIB, the routing table. The routing table shows us something else, but we know what is going on, right? We already know what is going on. Okay, behind the scenes, I should say. All right, so again, let's come back from that segue to pick up where we just left off, which is we've configured these two static routes on ISP1. So now we're going to configure floating static routes for those internal LANs. And this is going to be even easier than the first two next hop IPv4 static routes that we created, because now we're going to be creating next hop, and let me make sure that that's what it's asking for ISP configure. Oh, I'm sorry. These are going to be directly connected. So these will be a little bit different, but again, it's going to be very similar. So my route to get to the 192.168.10.16, and again, 255, 255, 255, 240, because 128 and 64 is 192, plus 32 is 224, plus 16 is 240. Those 4 bits that are being borrowed from the host bits. Now, remember, it says we're configuring a directly connected floating static route to LAN 1 through ISP2, meaning we're creating sort of a backup path here to go this direction to get to these two networks. And so what these directly connected floating static routes are doing is they're assuming, hey, this link here has exploded or is down or the line got cut. So now we want to come this way to get there. And since they're floating static routes, they will have a higher administrative distance than the two static next hop routes that are the two next hop static routes that we have configured, which are in the routing table, the RIB. These will not show up in the RIB. They're on standby. So let's clear the screen and let's pull up ISP1 here and let's finish this up. And again, it's directly connected, so it's going to be this interface here. I mouse over it in the activity and it's gig 00. So gigabit Ethernet 00, and there's that warning, right? Now, this is a legitimate concern. This is why this is our backup path, because we're not talking about recursion here with this message. We're talking about how Ethernet networks function, and that is using ARP, right? And that is using ARP. So be aware of that. And there's a note on page 136 6 in the text, 136. It should be on 136, which is right after the static route configuration that we're talking about, that mentions that the ARP process, right, has to happen when it matches a static route. And that does consume on Ethernet networks, right? And that does consume resources, but we're using it as our backup. So, okay, right? We're going to go ahead and suck it up here because we want the network to be up, right? We want reachability to be there. So we're willing to take a performance hit on the backup directly connected floating statics. And you know what I just realized is I did not read all the way to the end of the line, and we want that to have an administrative distance of 5. And so now we're going to do the same thing, except this is going to be a 227, and we're going to come over here and change our network ID to 32. And did I do that right on ISP1 configure directly connected floating stat to LAN 2 through the ISP? Oh, you know what just happened right there? Inconsistent. I'm glad it aired out there because I forgot to change the third octet to an 11. And what did I just do? I'm sorry. I put 227. I meant 224 /27. But ultimately, we got there, right? Typos happen. So I was saying it's a /27, and as I went to type 224, I'm saying 27, and I typed in 27, of course, right? So there we go. We've sorted out the problem. We're now at 50%. So let's go ahead and power through the rest of this activity. Part 4, configure IPv6 static routes to the internal LANs. And we're going to be doing all of this on ISP1. So we're going to say IPv6 route. And again, the syntax is the same. So my route to get to the 2001:db8:1:10:/64. Now here, I'm referring to the network. I'm not referring to a next hop IP. Therefore, I do need the prefix length in there. I need the /64 in there. And the question mark proves that that syntax is correct. If the syntax is wrong, incorrect, the question mark would come back and say, I'm not sure what you're looking for because something prior to this is wrong, right? Your syntax is wrong. And so now let's take a quick, let me make sure I don't diverge here. A next hop. Okay, so we're going to do a next hop IPv6 static route to the LAN 1 network through the edge router. And so we'd have to go back up here in the addressing table, and we need to get the edge router's serial 000 IP address, which is going to be that value right there. So let's say 190, oops, sorry, not 192. Let's say 2001:db8:A:1:2. Now, no prefix length here because I'm giving it the next hop IP. And so that would be our syntax. We're going to know right away here whether we go from 50 to 56, which we just did. So we're good there. Now, we're going to configure another next hop IPv6 static route to LAN 2 through the edge network. Now, this will be easy. We should be able to go up arrow, and the network is going to change. And the only difference in the networks, and let's make sure I don't mess this up here, it should be 2001:db8:1:11:/64. And again, we're using the same next hop IP address. And there we go. We've got that information in there. So we've got these two networks are done. We're at 62%. So now we're going to configure IPv6 floating statics to the internal LANs. And here we're going to be doing next hop IPv6 statics, just like we did right here. We did next hops for ISP1 going to the edge router. Now we're going to be doing floating statics with an administrative distance of 5 going to ISP2. So again, next hop, not directly connected. So we're going to need the IPv6 address of this interface. That is the next hop that I would take to get to these networks if the serial interface is down. And while I'm scrolling up here, let's see ISP2's gig00. There is my next hop IP. So again, I can recall for the first LAN 1 network, and we're doing a next hop scenario here. So 2001:db8:fox for F::fox for F::2. and that should give us a few points, and it does. Now, for the other net, oh, you know what? Floating statics with a cost of 5. And let me check something here. Do show run. Let me make sure that we did not get... All right, so what we're going to do here is it looks like the Fox... Oh, you know what? And it pulled the wrong command back up. So we've got something to sort out here. So that was incorrect. I did not want that. So let's do this. Let's double check. Make sure that we've got everything. Okay, so everything is in there good. But what we want is we want the... Where's it at? Through the 10. That is what we want there, was that entry there. So that is the IPv. I keep forgetting to put the floating administrative distance at the end. So this is the floating next hop static route to the LAN 1 network with an administrative distance of 5. And there we go. So now if I say do show run, we should see we have the 2 primary next hop static routes. And now we have our first secondary next hop floating static route. And now the last thing to do here is to just do LAN number 2, which is what we were being asked to do there. And now we're at 75%. So let's float down here. And let's check and see if your configuration's been completed correctly. You should be able to ping the customer server from the hosts LAN 1 and LAN 2. All right, well, let's give that a try. Let's pull PC1 up here, give ourselves a little more room with which to work. And the customer server, so let's give a ping 198.0.0.10. And I didn't want that. I wanted to put 10. All right, and let's see if we make our way out of LAN 1 to the edge router, over to the ISP, and we do. So we've got connectivity there, but let's make sure that we check from PCB and make sure that we can get there. And let's say ping 198.0.0.10. And take a look at that. We've got connectivity. But remember, we should have IPv6 connectivity as well. 2001 DB8 Fox 10. And that is working like a champ. We'll come over here. And again, we are expecting that this is going to work, but let's confirm DB8 Fox 10. And we've got connectivity there. So up to this point, all of our configurations correct. We're at 75%. Now we're going to configure what are referred to as host routes. So users on the corporate network frequently access a server that is owned by an important customer. In this part of the activity, you're going to configure static host routes. These are /32s. That is a host route. One route will be a floating static route to support the redundant ISP connections. All right, so this is good stuff here, because now we're going to do some host routes. And these are the longest match. A /32 is my longest match. All right, so we're on the edge router in user exec mode as indicated by that greater than sign. We're going to transition with the enable command, or just EN, to privilege exec mode, where we're going to configure IPv4 host routes. So on the edge router, we're going to configure an IPv4 directly connected host route to the customer server. And this is going to be my route to get to the 198.0.0.10. I'm not putting the network. I'm putting the exact IP address of the server, because it's going to be a /32 and all 255s in that dotted decimal subnet mask notation. That's a /32 host route. And when you go to work on firewalls, you're going to become very familiar with the command permit host and then the IP address of the host. Unfortunately, here when we're doing the route, we can't say host. That is how we say host, is by doing a /32. All right, and it's going to be directly connected out that serial 000 interface to the customer server. And it's going to go to ISP. Administrative distance of 5. Okay, so it's got to be that it's going to, and we'll find out right here. Because what I'm looking at right now is it says on the edge router, configure the host route to the customer server. It doesn't say, it says make it directly connected, but it doesn't say directly connected to ISP1 or directly connected to ISP2. I'm assuming we're following the same thinking that ISP1 is our primary. And our completion percentage, which did increment, is going to let us know that. And then I'm going to create a floating, and let's make sure we get the correct value in here, of 5. And that takes us to 87%. So there's my backup in case the link, that serial 000 interface link to ISP1 goes down, we have a backup that goes to ISP2. Now, we're going to do the same thing, with the host routes for IPv6. Okay, and here it says customer server. You notice the difference between the IPv4 and IPv6 instructions is here. It says through the ISP1 router. Here it did not say that. So here is how you do a host route, which is a /128, because it's IPv6 128 bits, IPv4 32 bits. Here is how we would configure that. And the edge router. So we're going to say IPv6 route. So my route to get to the 198, to get to the 2001 DB8 Fox 10. And remember, this value here, we can't just leave it like that, right? We want to put in the /128. And then I'm going to provide the next, of course, it's going to be the next hop IP, which I'm going to have to go look up on ISP1 up here, which is going to be on that serial interface 2001 DB8 where are we at? 2001 DB8 A 1 This is a next hop IP, right? This I'm indicating a host route. All of the bits are dedicated, are being used up. We're saying it's like a 255, 255, 255, 255. A /32 is a host route. A /128 is a host route. And it'll prove that when we jumped up to 93% there, that is the correct syntax. And so now let me come down here and look, because this is where direct. Oh, okay. So you see they switch it up here. So they wanted the primary through the ISP1 router to be a next hop static route. In other words, a recursive static route, which we know is the name to describe it and not what's really taking place behind the scenes every time packets are routed using that route. We're going to configure directly connected floating host route. And so we'll just hit the up arrow. And hold on one second here, because now I'm wondering, we did. Oh, I'm sorry. Oh, I'm sorry. I got confused. I confused myself there for a second. So everything is going to be the same, with the exception. This is going to be a lot easier. Instead of having to go get the IP address of that serial interface on ISP2, we're simply going to say it's directly connected. We're going out serial 001, and that should put us. Oh, and again, I leave off the 5, right? So let me pull this back. And let me say no on that one. And let's say do show run. Again, I left off the administrative distance. I apologize. And so where are we at on our IPv6 routes? And so as you can see here, we have the first one that goes out. And let's make sure that is the serial 001 interface, correct? It is serial 001. All right. So now let's rerun that command that we had just run. Serial 001 with, and if I do a question mark, you can see this is where we would put the administrative distance of 5. So we have a directly connected static host route to get to the 2001 DB8 Fox 10 /128. And let me make sure that that's everything. To go to ISP2 and no oh, I'm sorry, I had the no in there. All right, let's go back here. Typos. All right, so that should be the correct command. And let's say do show run and see if we are in there with the directly connected. And so we do have the directly connected. So now you can see we're stuck at 93. So something is missing here. And again, I'm sure that as I was reading through here, I missed something. And let me see, these are directly connected IPv4, and we've got those. So if we go to a check results, and let's see what it might think is wrong. So the static route 3, so it's showing that the IPv6 static, which is the one that we just did, it doesn't like that. And I had a feeling that we were going to run into a problem here when I incorrectly put it in there. So let's do this. I'm going to say write mem. I'm going to save my config. I'm going to go into global config, and let's say do show run. And here's what I'm going to do. I'm going to say no IPv6 route 2001:db8:fox:10. Let me double check that. 2001 db8 fox:10 /128 serial 0015. So I'm going to remove that. And here's what I'm going to do. And I'm wondering, it should give us an error. I'm packet tracer, I'm checking to make sure. Okay, good. So that should have been, let me pull this back here. I'm just checking to make sure that packet tracer is not expecting that, and it shouldn't, right? We should have to put the prefix length in here. And so here's where we're going to do a little troubleshooting, administrative distance of 5. And it doesn't like that route, 2001 db8:fox:10. So let's save our config. Let me reload this router real briefly here. And let me double check and make sure that it is on the edge router where it had the issue. Yeah, and it is on the edge router. Oh, the edge router just went down. So, but I was just looking for this right here. So it is on the edge router where the static IPv6 route is having an issue. And that is certainly the last one that we did. And let me make sure. We'll let the router come back up here. And we'll take a look, and we're still at 93%. Let me rerun the command IPv6 route 2001:db8:fox:, and it's got to be a little typo of some kind that I've got here, /128 out the serial 001 interface administrative distance of 5. And it doesn't like that. IPv6 directly connected floating host route to the customer server through ISP2, use an administrative distance of 5. And so that syntax is correct. Unless there's a typo in here that I am missing, that is going out the correct serial interface. And let's maybe do show IP interface brief. Let's confirm that. And it is the serial 001 interface. Do show IPv6 interface brief. And that is correct. So it's either it's not looking for that. So let's remove this. And again, hopefully you're not screaming at the monitor right now saying, no, it's this easy typo that you're overlooking. Let's say IPv6 route to get to the 2001 db8:fox:10, and I keep looking up there to confirm that that is correct, /128, and I'm going to use the next hop IP just to see if that is the issue, that it's not grading it based on that directly connected interface, that it wants the next hop IP of ISP2, 2001 db8:fox::fox::, oops, sorry, ::2, 2001, oh, wrong interface, 2001 db8:A:2, ::1, with an administrative distance of 5. And, oh, packet tracer, how I love you. All right. So the completion percentage is at 100. It asked us to create, the last thing it asked us to create was a directly connected floating static host route. This is not a directly connected floating static host route. That is a next hop recursive static host route. We're using the next hop IP. So it looks like there may just be a typo in here. And my guess is they wanted you to do directly connected, which would have been the syntax we had used right there. That would have been the correct answer. You're not getting the points because my assumption is that the grading engine is configured to grade just like step 2A, where it wanted the next hop. And so again, I love Packet Tracer, but sometimes it drives me crazy with things like this where you're trying to troubleshoot and figure out what could be going wrong. But that is your ultimate answer. All right, well, that is going to do it for Packet Tracer Activity 6.2.1, where we found a typo either in the instructions or maybe it's grading incorrectly. But what did we talk about? We talked about next hop, aka recursive static routes, where only the IP address is provided for the next hop. We also talked about the fact that in terms of that being some sort of a massive concern and that there's going to be performance problems, we saw that note that we looked at, which was actually from the version 6 curriculum Routing and Switching Essentials textbook. And this is one of the best notes ever that really drives home the fact that Ceph is there behind the scenes, and that even in the routing table, when you see that it says the next hop IP, and the explanation that you read about says, then there's a recursive lookup that has to take place to figure out which outgoing interface the traffic needs to go to get to that IP. Ceph has that all computed behind the scenes on the back end. And that is not what's really taking place. In other words, a static route using a next hop IP requires only a single lookup when Ceph is enabled on the router, and it's enabled by default, right? And then we talked about the semantics behind the directly connected, right? Meaning there's really no huge benefit there between directly connected and using the recursive next hop when we're talking about point-to-point networks, because there is no recursive lookup. When we're talking about Ethernet networks, yes, we've got ARP concerns there, right? There's going to be an ARP concern, and that's where you would want to use your fully qualified static route configuration. And so again, next hop recursive static routes. We talked about directly connected static routes. We talked about fully specified static routes. We looked at them from both a default route perspective as well as a host route perspective. And so hopefully now you have a much better understanding of how static routing works, the different names used to describe the different types of static routes, because again, recursive is next hop. That's what they're trying to say there from a naming convention. Whether that recursive lookup takes place or not all depends on whether Ceph is enabled, and it's on by default. And like I said, I'm hard pressed to give you a corner case where you would want to say in an enterprise network, hey, let's turn Ceph off. Because that is what Ceph is there for. It's there to optimize the forwarding of your traffic in the data plane, which is also referred to as the forwarding plane. All right, well, that is going to do it for this tutorial on Packet Tracer Activity 6.2.1. I hope that this has given you a better understanding of routing. Thank you so much for watching, and I hope to see you in the next video.